Hello, everybody, and welcome to today's vOLTHA TST. Thanks for joining. As usual, the call is public and recorded and will be shared on YouTube. So please be mindful of the comments you make and the information you share to the rest of the team. There's just two items on the agenda, but I think there's plenty to talk about. So the first one, device updates. I have not put that in. So I would like somebody, the person who did at that point, to please step up and take ownership of that.
Yeah, that would be Maninder. Are you online, Maninder?
Yes, I am.
Thanks.
So the idea behind it is, as we know from past few TST meeting, we have been discussing our device updates, and it is decided that we are going to extract those updates from logs. So I have tried couple of approach, and the two approaches which I am working on right now is we can extract logs using Kubernetes client as well as using Elasticsearch query. So before diving into any one particular approach, I would like to discuss on the idea and what are the pros and cons among these approach, and if anyone else can suggest any other approach which would be more optimized and efficient.
So one of the things I think we're trying to do is get the stop having to re-implement, change things, and re-implement, right? Get time to kind of a final decision on which way we're going to implement this. So if we're going to get this information from the log files, and if this information is available from kubectl logs, does anything need to be added to vOLTHA is one of my questions. In other words, if this state is already available through existing tools, is this feature then done at this point? Or do we need to add, call it convenience functions to vOLTHA? There is a precedent in vOLTHA to do such things. The whole component, vOLTHA component list, get whatever, is really just aliases to kubectl. So the question is, from a usability point of view, is it worth it to take that next step and put it in vOLTHA? Now, when we look at logs versus Elasticsearch, if we say, oh, kubectl or vOLTHA is going to use Elasticsearch, that then implies that Elasticsearch is a default component of vOLTHA, which I don't think we want to do. So my feeling is we want to stick with logs, with what's available in logs. And if a deployment chooses to use Elasticsearch, then they can search for these logs any way they want, but it's not a requirement. The only caveat with logs that I see is, of course, they are or can be truncated. So it's not necessarily a complete history. I don't know if that has any bearing on the decision.
So my vote to include anything in vOLTHA is no, because we can get that information through existing tools. So I don't see why we should just wrap those tools in vOLTHA. Regarding the logs versus Elasticsearch, I believe that a query in Elasticsearch is basically querying the logs. So how you want to consume the logs, then it's basically the operator choice. If you want to aggregate your logs in Elasticsearch, you are welcome to do so, and there are examples to do that. But if you want to do kubectl, get logs, blah blah blah, pipe grep, whatever the device reason is, that should work too. No.
My only take on that one is like with kubectl, we don't have a historical data, but with Elasticsearch we do have. So for convenience, if for example we have a deployment and something crash and want to go back, assume like there's some assume there's a multiple crashes, and the data we can't get it from kubectl, then we'll have to go to Elasticsearch. I don't know if it's that convenient or not.
But that's only if a deployment's chosen to use Elasticsearch.
Correct. But I thought like our deployment will use Elasticsearch. Like it's there's enough changes there, I believe, that make it kind of something that we will use, right?
Yes and no, in the sense that I would like to avoid to make that mandatory. If somebody wants a very lightweight deployment, you can go away from Elasticsearch, not deploy it. So
It's definitely not mandatory, but you have to know and accept that without it, you may lose some log history.
yes, indeed. But
And even with it, you may lose log history because you don't have infinite disk space. So you're going to be doing truncation, roll up of data anyway. So there's no way to avoid saying at some level, you're going to not have all data.
So I have a question. What is the desired outcome? Like, okay, we grab the logs and we get the reasons. What do we do with that? Because that to me is the outcome then shapes the desired or the required implementation.
In this case, it's not just a device reason, because it started with device updates in the sense of you can query the logs. Before it was not logs, it was key restore, but you can query the log now and try to figure out the historical updates that have been done on a specific device. Like, for example, like you have created a device, there was a request that was sent to the adapters, the device was either success or failure. So there's some historical information that you get with device updates, not just device reasons.
So the desired outcome is to have in some place or form an easy way to consume the different updates that happen to the device. That is the outcome.
Yes.
Okay.
An easy way to So is this a debugging tool, a troubleshooting tool, or something that we expect operators to use when the system's all in good state?
I think originally it was something in between. It was not purely troubleshooting. It was not purely something like an operator requirement, but it's convenient.
But when is it used? I mean, if would I really only use that if I'm doing system verification or if someone's complaining of an issue? I wouldn't say at 5 o'clock run this every day as a report, would I?
No, I don't think it will be run like that every day. Like I said, it's not an operator requirement per se.
I think it's a very useful debugging tool for sure, because if you are doing some changes or some tests and you can know the complete history of what happened to a device, that's very helpful. But if that's the case, then probably just getting it out of the log is enough, because when you're running a test, you're always capturing the logs and you don't have that huge amount of logs that will roll over or spill out of your disk.
So effectively what we're talking about is it could even be a shell script that just scrapes the logs.
I wouldn't know if it's a shell script or if it's just filters on kubectl.
Sure. Okay, fine. A set of filters. But a README file with a couple of commands that tell you, okay, this is the way you do it.
And I think that's the question. Is this a documentation issue or do we want to add the commands to vOLTHA?
I would say we just kubectl get logs, filter, and do with that, because it's effectively, if we add it to vOLTHA, it's gonna duplicate, as Theo said.
Yeah, I agree with that. If Elasticsearch is not part of vOLTHA, then we might as well use kubectl.
And also with Cube, I mean, there's nothing preventing us in having both. I mean, this is like, okay, let's create that kubectl command. Great. You have Elasticsearch, you might have better luck and better history and more data. Do it this way. And that's
Yeah.
it.
Yeah, everything that is in the logs will end up in Elastic Stack, so you can query it in some ways.
Yeah, I understand that. What I'm saying is like the change that Maninder will do, if he does any change in that area, it's already using kubectl. You won't make any change in vOLTHA to try to query logs Elasticsearch.
No, I would say we avoid that. And we have either kubectl get logs with a few filters, and that maybe gives you the amount that is not rolled over, and it gives you like the past hour or so, depending on the log level and all of that. And if you want more, the requirement is you have Elasticsearch, and we provide you the queries to get that from Elasticsearch.
My question is, what is the log level we envision?
That's a very good question
for this history.
For this history, it was envisioned to be info level.
Yeah, but that will also mean that if I run my system as I expect people to do in production at warn level, then we won't have this information at all.
Yeah, that's correct.
That's why I think originally this was thought of not putting it through the log system, but add it to the etcd or some other storage mechanism, because it's not necessarily log information, it's system state information. But with the decision of moving it to the logs, at least temporarily, until we do some restructuring of vOLTHA core, it moves into the logs. But yes, I agree. Unless you're explicitly listening for this stuff, you set your debug level at info, you're not going to get it.
And that could be fine, because being a troubleshooting tool, mainly you may just turn on the logs to info to debug a particular issue, and you'll get the action that happens on that device from that moment on.
Right. It could also be its own category, logging category, i.e., I'm logging at info level for device state. Right? Because don't we have a category associated with some of this stuff?
Yeah, I think if it's in his own package, we can set his own independent log, so you can run the rest of the system at warn and that particular component at info.
Does it have to be, I guess, yeah, it's called package, but is it really just a text identifier? It doesn't have to be the package, right?
I think the log is by package, which is the text.
I'm sorry, I didn't catch that.
The log is by the package.
But don't I explicitly tell the logger what quote unquote package I'm in? Can't I?
It's well, the log have changed quite a bit, but it can automatically detect the package in which you are.
Yeah.
Yeah, I thought the library was looking up the Go package and using that to index the logs.
Now that's something we can investigate.
Yeah, because that's something that, to be honest, is great for a developer, bad for an operator. I don't think an operator thinks about the structure of the code, how we developed it. They think of, I want to log on this category of things. But that's a separate issue.
Well, unless the code is divided in categories that make sense.
If your structure of the code happens to match the same categories that an operator thinks, then yes, then you're good. But I would think categories sometimes cross-cut code structure.
Well, so let's. So I think let's continue. So let's get an assessment on this. So the decision was to create some documentation with two sets of commands, one for the kubectl, one for Elasticsearch, that grab for a particular log that Maninder is putting in. Let's put it at info level, and let's investigate if we can set to vOLTHA just that particular log or that particular thing to a label to the info level to avoid everything else, leave the rest of the system to warn, and just set this one to info level. Is that the right way to proceed?
Sounds good to me.
Makes sense to me.
Yeah, sounds good, but the last part, I doubt. Yeah, you will be able to do that.
I mean, as it's not exactly contingent to the work that Maninder is doing, meaning that the work is still valuable with setting it to info, and this is an add-on to it. So I feel that let's start the work, and then when we set it to info, and then after that is done, then we investigate if we can set a label to it, and how much would that entail in changes and things like that.
When you meant a label, you mean a label in the log, or are we talking about the label like a category that gets set by vOLTHA?
I think the idea is after we get this just working with log info, right? Which means we're going to get this and a lot of other stuff potentially. The idea is, can we create categories in the logging or use any text string as quote unquote a package level for the logging configuration, so that these logs could have their own category. So the whole system would be on warn, but this specific category just to show these events and nothing else would be captured with info. But that's a secondary step.
Yes, exactly. So the work can still be done at info level. Let's get that done. Let's have a final point on that, and then we start the next level of investigation, which around logging, which I believe is valuable because it might affect a lot of other things. And this was something also that came up in the OpenONUGO discussions some time back, to have a per functionality log, okay, or per category logging, not just per package logging. But that's,
and I think if the investigation is to see if that's possible out of the box, if it becomes a huge effort, I don't think we're going to go down that path right now.
no, I mean, again, it's an investigation.
Yep.
So, and let's see how difficult it is. Maybe the logging framework that we use supports that, and we don't know. Maybe. So let's investigate on it. But really, the outcome of the discussion that we started with today is, let's create the commands for both Elasticsearch and the kubectl, and put them in a document somewhere. Where that somewhere is, the vOLTHA docs is probably my link.
Okay, got it.
Thanks. Awesome. Okay. Glad we reached a conclusion on that. So next up is a discussion I put in, which I've been talking a little bit internally within ONF, especially with Theo. And we feel that before we can go ahead and come up with a set of practices topics for a software upgrade and LTS release, we need to decide exactly what the fate of our storage is going to be, because that is a key point of having the capability to upgrade. And why is that a key point? Because if you upgrade a service that holds some state within a database, and the information structure changes from the version of the software you're upgrading, you need to adapt, be either backwards compatible or do some transformation of the data that is already in the store. Instead, if you don't have a store and the information can be relearned from the service, from other pieces in the system, the data that service relearns and the information that it has, it's its own internal state without having to rely on an external database where the structure is mandated before a release or a change of data. This also ties back to some of the limits that we have seen with the TCD in terms of scalability, in terms of weight of the whole system. Is it the right choice if we want to go down that storage path? So I put it in more of as a discussion topic, but what I would like is that in either this meeting or the next meeting, we reach a conclusion on what we want to do with the storage, where the conclusion might be we go away from storage in vOLTHA and we decide that we can relearn everything we need upon restart of a component, of a vOLTHA component, from either the hardware or ONOS or the higher layers. Or we decide we keep a TCD and then we put in place options for practices for allowing data structure to change across versions and keep the data information in a TCD consistent. Or we decide we go away from a TCD and we pick another storage system, a database, whatever, that is more flexible, less heavyweight, and maybe enables better data upgrade capabilities. So this is the context for everybody. I would like to hear your thoughts on this.
I do not think doing away with storage is feasible. I mean, there is a suggestion here that we fetch everything from hardware, but not all hardware might support this functionality. So probably a good idea is to revisit what we store on, etcd or any other storage, so that we are very optimal on how we use the storage.
Do we have an example with which we work at where the hardware doesn't store the information? Or is this is this kind of it's possible hardware won't store the information?
Well, I have experience working with BAL, Edge Core, which uses
Yep.
the underlying platform as BAL. And we cannot really, there are no APIs to fetch all the required information to reconcile if vOLTHA stack goes on reboot. So
agreed, Girish, but maybe you don't have to reconcile it from the hardware, you reconcile it from ONOS. For example, the flow.
Well, I'm talking about the PON resources, the technology profiles.
Okay.
The gem ports, the alloc IDs.
There are big problems here, I think. The first one is the thing that Girish mentioned.
Mm-hmm.
we have a resource manager in vOLTHA adapter, and it creates some resources like gem IDs, unlock IDs, like that. So they are created by vOLTHA and kept in etcd. So I think it's hard to request these resources from anywhere else. And the second one is the, say, some kind of memory of the processes. I mean, adapters and perhaps, I don't know, perhaps W core, RW core also keep some in-memory data, I mean, generate some in-memory data and dump them to etcd in order to use them during reconciliation. So these are some kind of state informations or some runtime information generated by the processes. So the reconciliation generally depends on reading data from KV store. So this is another problem, I think.
So I come back to where's the authoritative source for each bit of information. And if, for instance, ONUS is an authoritative source for information that vOLTHA is somehow caching for whatever purposes, I would argue that we might want to just use the authoritative source and not cache that into etcd. If we're caching it, if we're not doing that, then the question becomes, what is the value of trying to keep that data in sync in vOLTHA with the authoritative source?
But David, ONOS doesn't know everything, right? I mean, the whole point of vOLTHA is an abstraction, right? So ONOS doesn't know anything about pawns and pawn resources and what's...
I agree. I'm saying if, that's why I say, what's the authoritative source for data? I didn't think ONOS is the authoritative source for all data. I agree. But where it is the authoritative source for data, it should be the source for the data.
Yeah, it's spread through ONOS and vOLTHA. Like vOLTHA doesn't know about subscriber information or subscriber services. ONOS knows that, right? And likewise, ONOS doesn't know about pawn resources, low-level pawn resources, which vOLTHA knows that. They're both controllers in some sense, right? So they both have information that they are the authoritative source for.
But it is true that if you look at some of that information, it is duplicated. For example, the flows. While it's true that vOLTHA decomposes them properly for each adapter, it is also true that that operation is not something that needs to be stored. We can do it on the fly again, and those flows get stored in ONUS, and that's one possible data that is getting duplicated, to David's point. But
flows in vOLTHA, hold on. Flows in vOLTHA also then come associated with pawn resources, right?
Exactly.
So it's not the same as the flows in ONUS.
It is not.
You assign some IDs and gemport IDs, alloc IDs to specific flow to the flows, right? ONUS has no information about that.
Yes. So
am I right, Girish?
Can vOLTHA rebuild those flows without storing all the flow data, I guess, from ONUS? Can it essentially say, here are the pawns, here are the resources I manage, and they're associated with the flow ID, which is an ONUS flow ID.
Yeah, but where do you store that association?
Pardon?
Where do you store that association?
What Girish is saying is that, first time when the flow came and I associated some resources to it and I pushed it down to the hardware, I assigned some IDs, right? I need to store that information. So the next time it comes, yeah, I can recreate a flow and reassociate some IDs, but I actually already pushed something to hardware and I gave IDs to those things, right? If I don't store that, I lose that.
Yeah,
right? I don't know which IDs I already associated earlier, right?
But again, if I store that in memory, and then I not KV, how's that change our memory footprint? And what other failure scenarios if the component goes down that I would potentially reprogram the device with new gem ports and everything else?
Yeah, at least from my understanding.
Yeah, if the device goes down, I mean, you clean up everything internally in the vOLTHA stack, and you would recreate them, new IDs. That's fine, but the issue is if the vOLTHA stack itself goes down and comes back, the issue is reconciling all that information from the hardware.
So really,
if VOLTHA goes down, that was actually my original point. If VOLTHA goes down, and we're storing things in volatile memory, then we would, when VOLTHA comes back up, it would essentially reprogram the device with new gem ports.
No, it should
Why
not.
Well, at the moment,
because if you reprogram the device,
at the moment it does not. At the moment it does not, because that information is stored in a TCD. What Girish is saying is that if you don't store that information, and Saraf was also saying this, you don't have a way to map what is there already on the device to what you want there to be. So yes, you will, if you don't have that storage and you come back up and you have no way of getting that information out of the device, you will end up reinstalling different gem ports. At least this is my
Now, the downside to that really would be, I would think, is once the device is set up and the data plane is operational, if VOLTHA crashes, we would actually cause service disruption in the data plane.
Yeah.
Yeah.
Now, are we storing flow counters in etcd that are then passed up to VOLTHA?
I think we don't. We only keep configuration.
What do you mean by flow counters? Are you talking about flow IDs?
He's talking about packets matching flows, packet counters matching flows.
Yep. Are we storing those in etcd today?
Don't think. Well.
No, we don't. Fetch that information. I mean, that information is available at least on BAL, but we don't fetch it currently.
I thought we do, and it goes to Kafka. I know it doesn't go to ONAS.
Oh, we store port count. I mean, we fetch port counters, but not flow counters.
Okay.
But yes, if we want to go back to the previous point, if we want to avoid service interruption, saving that flow ID to data plane resources mapping is required. Is that a correct understanding, Girish?
Yeah.
Okay.
So,
because there is no way. Because there is no way we can relearn that from the hardware. There's really no way we can re-get what associated stuff, what provisioned elements already there.
I wouldn't say there is no way. I mean, it's possible, but I mean, you really depend on the hardware capability here. I mean, that's my whole point. There are ways to do it. I mean, even if the hardware doesn't support it, you could have a wrapper application around your underlying platform that stores this information and, reports it back to VOLTHA stack. I mean, you can work around all this, but I gave you example of tech profile, gem ports, alloc IDs, but then there is MIB templates, MIBDB. I mean, there are a lot of other stuff that gets stored on the KV store. Instead of just removing the KV store altogether, maybe we need to rework on what we actually store on etcd. Optimize it.
That is definitely a valuable point, and this is why I wanted to bring up. Right now we're talking about one extreme, which is go away with the TCD. Well, not a TCD, storage entirely. And there are a lot of things that can happen between where we are right now and like completely removing that storage. The benefit of removing the storage is that we would have one less pain point when we decide to upgrade a component.
Okay, so there's I think we've answered the first question. At least some of the hardware that we want to work with does not allow us to easily query the information. So yes, we could put a layer in between VOLTHA and the hardware, but that's just kicking the can down the road. It's not actually addressing the problem.
Well, yeah, so, yes and no, David, at least in my mind, because if and I was just thinking about this. This is an interesting point, because if you treat the hardware as a source of truth, you treat the box as a source of truth. If the box and whatever is on the box is still alive, you treat it as it's alive, it's well, I can get stuff from it. And for himself, he is his own source of truth. And so the information is there while the box is up. If the box is still up, you can get that information. If the box is not up,
I thought we were just heard that we cannot get the gem port and a bunch of other information from the box.
But Girish said you can save it in an application.
That's what I mean. All we're doing is we're pushing the problem to somewhere else, and we still have to solve it at VOLTHA. Because I mean, if we push it in the box now the code on the box now has to keep track of this stuff as it comes down, and store it somewhere on the box, and be able to respond to VOLTHA when it asks for that information. This goes back to the question I asked: is if none of the boxes we are working with today or plan to work with in the next 6 months have the issue, I mean, they all, phrase that different way. If the boxes we have now and the boxes we want to work with the next 6 months all have the ability to query the device to get all the gem and all the other information, that's one issue. Then we might say, okay, for everything we're planning to support, we're good, the box gets it. But if there are boxes that we work with now or planning to work with in the next 6 months that don't have that, then I think we, VOLTHA, have to deal with it.
Any other thoughts?
I think from what the gist of this is we will need storage. How much we don't know yet, because maybe there's some cleanup that are required. etcd is more a storage for config, or the data that we're storing config data, or they are more like a transactional type of data. That's something else that we could explore. Will etcd meet our requirement? Because we're already seeing like persistence problem. And I think the size of the data that we have today, it's not huge, but once you start to add a lot of bigger clusters, I believe that we will be like bordering to the max of what etcd can provide as storage.
Once you add a lot of what? I'm sorry?
Once we have a bigger clusters, like a lot of VOLTs, a lot of ONUs, a lot of flows, a lot of all those profiles, I think we'll be flirting with like the limit of what etcd can provide in terms of storage.
So you're suggesting that etcd's transaction rate is not good for for VOLTHA configuration. So separate the data that's configuration from what's more, I think you call it transactional, but not configuration data. So if we just look at the configuration data, how often is that changing? And what is the transaction rate for that? And does etcd meet the transaction rate for that? In other words, is etcd good for some of our data, but not for data that is more streaming, monitoring, high rate of change?
Yeah, etcd is good for config, pure config that don't change much. But once we have things that we have a lot of queries being done, then that's not really what etcd was meant to be.
So what is the data that is out of alignment with etcd's design, if you will, design base? Which of our data is making, what data are we querying too much? What data are we writing too much for etcd?
I think that's something that we'll have to figure out. Like, for example, is tech profile config, or it's something that we query that all the time? There's a bunch of resources that we query all the time. I think it's something we'll have to figure out.
Tech profile is something that we do very often. I mean, every time a subscriber is provisioned.
And so some of that could also, okay.
Go ahead.
So with etcd, we can do watches. With a lot of KV stores, we can do watches. So I don't know how the memory footprint changes if we say, look, for these things that we read lots of times, it makes sense to essentially do a fetch and watch and keep them updated in memory, but have persistence backing for when our memory we reboot, and just query them on reboot as opposed to query them every time we need them. And this is regardless of if it's etcd or SQL or anything else. It's often more efficient if you have the capability to grab it for things that, again, change slowly, grab it, and then just watch for change. So I think, Gresh, back to your point, I think, yeah, we need to reevaluate how we're doing storage, what we're storing, as well as how we're using it.
Yeah, definitely need a lot more data points on what we store, how many queries are we doing before we take any decision.
I think most of the data we are keeping in etcd is also cached by the components. RW core, OLT adapter, or ONU adapter, they all, I think, keep the, say, one copy of data in memory if the data is used frequently.
So what?
Yeah, I mean.
So what you're saying is, sorry, Girish, go ahead.
Yeah, so I was trying to say that anything that can be reconciled is not really stored on etcd. It's locally cached.
So Mahir, what you're saying is that most of the access to etcd is something that happens on a need-to-need basis when reconciliation needs to happen, or because we actually write to the local cache and then the local cache synchronizes it with the etcd.
Yeah, for example, in RW core, I mean, the device structure itself is, I mean, we query a lot of times for the device. So we cache them in RW core. So in get operations, we use the cached values. But if there are some sets operations, then it hits the cache and also updates the etcd. This is the same in OLT adapter and ONU adapter commonly, I think. Because
so basically what you're saying is data access to etcd is already optimized to use caches along the lines, or somewhat along the lines what David was suggesting, right? That you pull it once and then you watch it for change. We may not be watching it for change, but we're certainly using the cache. Yeah. But then again, when we persist etcd, we still have issues at scale, right? So it's even though so the question is what's going on when we persist, and do we need to persist? So in
idle time,
ONOS, we're not but in ONOS we're not persisting atomics.
Yeah.
And we're just saying that, yeah, it's a cluster. If the entire cluster goes down, sure, you lose. But should we just take the same approach with etcd, saying, well, etcd is a cluster as well. Let's not persist it. If it all goes down, then yeah, we have to restart the system. But then all these discussions go away in some sense, because we still have a storage, we're still caching, we're just not persisting, and we're depending on the cluster.
The problem is during the idle time, it's not too much. I mean, we don't make too much queries on KV-store. But the problem is when you restart devices or something bad happens, I mean, like OLT is restarted or a component is restarted, then the way that we process these things is going to clear all of the data that vOLTHA has and clean all of them and rebuild all of them. If an OLT goes down, then we clean all of the flows. I mean, all of the ONUs, ONU IDs, device data, etc. I mean, everything is clean. So we rebuild them again, and this happens, in a restart time. I mean,
right, it's a thundering herd problem, right?
This makes a problem.
Yeah, it's a thundering herd problem. It's the worst case problem. So still need to find a solution in that worst case, in that thundering herd case.
But we're seeing that issue only with persistence enabled. At the moment, we fixed the thundering herd issue. So this goes back to your question, Suraf, is not having persistence fine? Because we treat that deployment of 3-node etcd cluster, 3 or more node etcd cluster, as a good enough resilient system. And we say, if we lose data from that, it's because all of 3 of them are gone. And so it's like, basically the whole 3 servers shut down, and we are going to have problems everywhere, not just in etcd.
If we don't have persistence in etcd, why do we have etcd? Why can't we keep everything in cache in the containers?
etcd is a synchronization of the caches across processes at that point.
Yeah, I agree.
And if your component restarts, you can still pull stuff from etcd, assuming etcd hasn't all crashed, the whole cluster, right?
It's essentially a shared cache.
Yeah.
Are we actually using it as a shared cache? Or all components, are we actually using it as a shared cache? Like, do we have 2 components that is doing the same thing and using access to etcd, like, for example, processing the same IDs, and 2 components like reading the same IDs from etcd as a cache?
But you've also separated it into a separate process, so you've got a different failure zone for your data than you do for your processing. So even if no processes are overlapping with that data, if the process that's doing the computation dies, the data isn't necessarily lost because it's in a separate process. So you've got different failure zones. That's, this is memcached. This is what all these do. Even Atomics does this. So there's reasons to do that. The question that I have is, well, many questions. I mean, if we decide that, again, it's okay in the disaster case to cause disruption, then yeah, we can get away with no storage. But I think we've kind of decided that's not the case, because we're in the case of the core crashing, we don't want to disrupt the data plane. Now the question is, do we believe etcd in a cluster, non-persistent, is sufficiently stable enough that the case where we have a failure in the software side, happens rarely, so rarely that it's not going to impact our operations and productions. The other question I have is an etcd that I'm operating in non-persistence. Can I take a snapshot of the data and back that up? So in the case where I do lose a cluster, I could potentially reload that in-memory cluster from persistence or from a snapshot and get back to an almost normal state.
Given that our system isn't that active, it's not always doing things that we are storing to etcd, just like Maher was saying, there are less chances of a snapshot being stale. Your snapshot idea may just work.
It depends on, I think, the subscription rate, right? If we have subscribers coming on and off thousands an hour, then you could potentially lose the last hour. But if I'm running in Manhattan, losing the last hour, which might be, call it 10,000 customers, is better than losing all billion.
But so the other thing that I wanted to focus on is we're focusing on a TCD. Are there better alternatives out there?
Netsia was trying something, right? With I forgot what they were trying.
It's Redis. Yeah.
Redis, yes. Have you tried it at scale with persistence?
We are still trying, yeah. I mean, Redis itself has some problems during, especially on scanning. I mean, our list methods on etcd, each CD has a directory structure, kind of keeping data. And so getting a list of things is easier in etcd than the Redis. So Redis, we need some kind of improvements in this scanning or listing issues, but the other things are going good. I mean, Redis is say better than the etcd when you look at the performance.
With performance with persistence? Sorry, performance with persistence?
Yeah, with persistence, yeah.
But this is performance. How have you tested this? If you tested both Redis and etcd in vOLTHA with persistence,
yeah,
at scale and seen better performance. I'm just trying to understand, was this, hey, let's run, create a test that's etcd versus Redis, or is this usage of etcd and Redis in vOLTHA that you've been testing?
We did tests with etcd persistent and Redis persistence, yeah. Say the Redis, I don't remember the numbers, but Redis is better than the etcd. I know that. So we're now testing for tens of thousands of ONUs, and we're now using Redis per stack to go for over 50,000. And I mean, but as I said, I don't remember the exact numbers. I mean, what's the performance of the etcd per second? But we had problems in etcd when you open the persistence. We have problems over thousands of, I mean, even hundreds of ONUs only.
Does Redis have a HA capability, or is it just persistence back single process?
It is, I think it's cluster like etcd, but it's not strong consistent. So it doesn't, the difference between the Redis and etcd is commonly this consistency issue. It doesn't guarantee that a written thing is shared to all of the clusters before the responses turned back to the user.
Which would account for some of the performance differences as well.
Yeah, but I don't know if this is a crucial thing for vOLTHA.
Because we're caching everything. Because we're caching
Yeah.
everything. So we expect that the most of the operations are going to go against the cache. And in the meantime, the backend will actually be consistent because it will have the time to be consistent. Maybe.
What do you mean we are caching everything, Angie?
What we were discussing before is that most of our services in vOLTHA do have a write-through cache for stuff. So if the backend, no?
Not really sure about that. I mean, especially Mahir would be aware of this. So when two ONUs query bond resources, it's required that your database be strongly consistent. Otherwise, you could end up having same resources given to both the ONUs, which would cause problems on the data flow.
Yeah, you may be right, but I mean, these all things are restricted on vOLTHA side, I think, with using logs, mutex, etc. And generally, we say we set adapters to deal with the device that the other one will not deal with it. So I think this kind of things, restrict the problems that you mentioned.
So maybe, given that we are at the top of the hour, I think this was a very useful discussion, and we learned a couple of things. One is that we need storage, and the second one is that etcd might not be the right solution. Yes, please go ahead, Mahir.
Another point on the discussion of whether we should go with persistency or not. We talked this in another meeting, I think. When you disable etcd persistency, then the cluster doesn't work well. When one node of the etcd goes down and comes back, it cannot join to the cluster if persistency is not enabled. So this is another issue with etcd.
Try that again.
I mean, if
I have a 3-node etcd cluster and I kill one of the nodes, so now I have a 2-node cluster with quorum with those 2 nodes. If I start up the new 3rd node, it won't join.
Yeah, because some information about this, let's say, I don't know, this cluster is kept in persistence, they persisted. So if you don't persist this data, then when the 3rd one comes, it doesn't know if it's correct, say, it's the node or not, and doesn't allow you to join the cluster. So you cannot, I think, set in etcd that persist this kind of data and do not persist the other one.
So the scaling issue, though, it's really related to which chart you use. That is an issue that I saw with the Bitnami chart, but that issue is not present if you use a different set of charts that were the incubator ones. With the incubators ones, you can scale up and down even without persistence.
Is that an issue of the chart there, or is that an issue of the etcd version? Because I remember that we had to move also a minor version of etcd.
I don't see how it can be an issue of the chart itself, so it's probably something in the version, but I haven't spent much time investigating it. I just noticed this different behavior.
Okay, so given that we are at the top of the hour, what I would do is I would ask you, Mahir, if possible, to compile a better a set of results out of the testing that you are doing within Netsia, and maybe share them in a more formatted way. Like, okay, this was the problem with Redis, this is the solution. This is the downside of Redis, we fixed it this way. So we might look at that as a possible alternative. And in the meantime, there are also a couple of other things that we might want to do. One is check out this version difference for etcd. And the other one is understanding really the persistency thing with our operators. Because, again, maybe it's good enough to say we don't enable persistency and just use a snapshot. So I would like everybody to now focus on the fact, okay, we decided that we will have a storage. What's the best storage going forward? And if you have any information about this choice, I would like you guys to come up with it. As I said, Mahir, if you can compile this Redis study that you have done, that would be great.
Okay, I'll check on that.
Thanks. So next time we're actually going to look at this one. And in the meantime, we can maybe possibly look at some of the incubator versions. What's the difference in there? Okay, any other thought? Anything you guys wanted to add? I'll keep this topic on for next time.
Just keep in there consistency models, because I know you have it there, but not strongly consistent. Eventual consistency around resource management is scary.
But may not be scary in vOLTHA context, but let's see. See, it's, we don't have multiple instances of, say, the vOLTHA adapter trying to do anything on the same device. So if it's not strongly consistent, yeah, if it's eventually consistent, fine.
Wherever resources are being allocated, that has to be strongly consistent to multiple. Wherever resources are being allocated to multiple identities or subjects, targets, whatever you want to call it, right? We can't have two people trying to read the same resource pool, and that resource pool not be consistent.
Yeah,
we may not have that case. We may not have that case, but you don't want to give out the same gem port to two different places.
Two people trying to read the same thing only matters if two people are trying to do it on the same device, right? So we may not have that.
Right,
So,
you have those borders. You have those borders, agreed. And we just have to be very careful.
It happens when we allocate resources for two ONUs. I mean, they're on the same OLT device, but they're on two different. I mean, there are two different ONU devices. We do have this case, but Mahir was saying we can work around this by using synchronization using mutexes and such. So ensure that devices and we allocate resources serially.
Because they're still on the same OLT adapter, so I'm saying this. If we will use only one OLT adapter for one OLT, then it's still on a single OLT adapter and we can control it.
Yeah, but how much time does it take to become consistent? I mean, you may use mutex, but the next time you query, are you sure that the data is consistent?
So just a query here. Wouldn't the consistency problem come up only when we try to access the same data through different members of the cluster? If we are going through the same member of HCD instance, which is handling that data, then it should be okay, right?
Should be.
Yeah, in etcd, yeah, that's fine, but I don't know what Redis.
Yeah, I think it would be for any HA cluster, right, which is eventually consistent.
The point being that I was trying to raise is changing consistency from kind of strong consistency to eventual consistency needs to be done with caution and thought. Not that we can't do it,
Yeah,
but I think we have to be careful about it.
Okay, to be continued. Yeah, I think.
Okay, thanks everybody. I'll publish the recording. Please, if you have any more information on this, just compile it. Your thoughts. We're going to talk about it again next time. But we do need to reach a conclusion fairly soon, because we need to start putting in places processes to allow the data there to be working with multiple versions of our code. So as soon as we settle the storage issue, we're going to then talk about that capability of handling multiple versions of the data with multiple versions of our services. Okay, thanks everybody. I'll publish the recording. We'll talk to you next time. Cheers. Bye-bye.
Bye.
Bye.
Right.
Bye-bye.